Fantastic. Welcome everyone to another episode of Index Office Hours. Today is the 21st of June and this is episode 64. Thank you all for attending. Today's going to be a very exciting discussion where we have a little bit of an open discussion. So if you'd like to get involved and participate, as today's going to be an interactive one, when we get into the interactive section, please do go ahead and raise your hand and then unmute your mic and feel free to fire away. So, as we do with all episodes, we're going to start off with opening remarks. And how we start off opening remarks is we give a shout out to 𝗨𝗀𝗂𝗧𝗧, the one place to go to keep up to date with all of the latest news in the ecosystem. Cool. So, today's shout out is for episode 69, and that is with the co-founder of Decentraland. So, Decentraland is obviously a huge project that's been around for a while, and this conversation was a very interesting exploration of the metaverse. You know, the founder used to work at Google and in the world of Web 2, and he discusses why he thinks decentralization is important and how he transitioned from the world of Web 2 to Web 3. So if anyone is currently making that transition, I highly recommend listening to this podcast. So there we have it. That is the shout out for 𝗨𝗂𝗧𝗧. And that is the opening remarks. So I'm now going to hand it over to Anna to bring us into Repo Watch.
Thank you, Abel, and hello, everyone. So on our regular segment, Repo Watch, links to all of the release nodes and PRs can be found in the agenda. And I want to remind you before we start with major blockchain clients that we've updated the flow to only include the clients that have had new releases. Also, Ethereum has stopped creating new releases, so the last release is version 3.3.5. You'll still find it in the agenda, but not moving forward. So, in terms of new releases, on Aragon version 2, or Ethereum block version 2, we have had quite a few releases. So the first release, 2022-06-03 alpha, introduces support for Grey Glacier, introduces support for safe and finalized block numbers for RPC queries, updates the skip analysis optimization threshold that leads to faster initial sync-in for Ethereum, BSC, and Polygon, and fixed go routine in Sentry. Next version, so 2022-06-04 alpha, that has been the first version that's added support for BSC Euler hard fork. It has a few bug fixes from the previous release. It fixes the handling of consensus layer nodes that are syncing from scratch against Precinct Aragon. And it has additional fixes. Version 2022-06-05 alpha. This fixes a bug found in the previous BSC Euler fork implementation. Fixes some regressions for ETH mainnet initial sync, and upgraded to a newer Roaring bitmap library to fix regressions. And the newest version, so 2022-06-06 alpha, it simply contains a hotfix for the BSC Euler hard fork. So if you want all of these fixes, you should be going to the very last one, so 2022-06-06 alpha. On streaming fast Get, we have had a new version for Get, so version 1.10.19, Firehose 1 and 2. On Get, we have had a new release, so version 1.10.19. Now, this contains some good changes, so updates related to the merge on Ropsten, which is now officially a proof-of-stake network. It supports block overrides for RPC method. It contains a new diagnosis tool get snapshot inspect account that allows you to investigate your snapshot data. But most importantly, this release contains some things that you should be aware of that will cause incompatibilities. So the engine API will now only be available with JWT authentication. So if you don't use JWT authentication, it will break your setup. Get will refuse to start if legacy receipts are present in the database. So you will either have to get rid of your legacy receipts or use the flag ignore legacy receipts. RPC method debug trace call will reject executions against the pending block, and RPC timer metrics have been changed into histograms. That's a lot of stuff. Has anyone had any good or bad experiences with upgrading to any of the Aragon releases we've mentioned, or has anyone tried the new Get release with its incompatibilities? What has been everyone's experience this week?
Hi, can you hear me?
Yeah.
Hi. Yeah, I had an issue. It was a fresh sync of 6.4 Aragon Alpha. It synced fine and it seemed to be working fine. And I put it in prod for about a day, but then it errored out, and it would only return a null block on a specific block, syncing 721 subgraph. I put it in Aragon earlier, but I upgraded to 6.6 and it seemed to resolve my issues.
Thank you so much for telling us about that. It does sound like 6.6 is the one that has a lot of. It seems like the stable one. Anyone else? Okay, then I will move on to the graph stack. So on GraphNode, we haven't had any new releases. And on Indexer Service and Agent, we have had the new release, so version 0.19.3. So thank you to our contributors, Ford, Hope, and our new contributor, Juan. And in terms of changes, so there's been updates into the native modules precompiled to include more node versions. There's manual allocation management that we've been talking about over the last few weeks. Some updates into the documentations, some bug fixes, Dockerfile update to a new image, so node 1615 Bullseye Slim, and upgraded cost model library. Thank you for all the contributors. And has anyone tried to upgrade to 0.19.3? I will take that as a no, or no comments.
Well, I upgraded on testnet, but I haven't been able to test it thoroughly yet.
But you haven't had any issues when you upgraded?
Thus far, no, not that I can tell.
Awesome.
But I need to. I basically need to try to migrate from 18 to 19 again to see if there's any issues, because I know for a fact that there's the place where most issues arise from. But I keep you guys posted.
Thank you. Awesome. All right. Anyone else?
Yeah, I just had one question about the upgrade. Does it do any migrations or anything that's going to be hard to revert if we need to downgrade again?
So it's not mentioned in the release notes. Yeah, it's not mentioned in the release notes, and I don't think Ford is around, but it doesn't seem like to me. It looks like it's straightforward then.
I would guess that it does, just because manual allocation management is pretty significant new feature. And I would just guess that there is, certainly new state that index or agent needs to keep track of, and that would obviously be persisted in Postgres. I guess that doesn't mean it's necessarily like a backwards incompatible migration if it's solely dealing with new state, but I would assume there are migrations.
We had some issues already into the latest version. It was related with all rules in the database, so we had to clean the all indexing rules, and that's the work.
Thank you so much, Brian. Kai, do you have any more questions?
No, that was it.
Okay. Thank you, everyone. Over to you, Abel.
Thank you so much. Oh, I guess I'm going to throw it straight back to Juan, actually, for Protocol Watch.
Hey, thanks, Abel. Can anyone hear me?
Yep,
Loud and
loud and
clear.
clear.
Awesome. So we have a short episode in Protocol Watch, but it has a few important changes, particularly forum governance, because everything else has no new changes. Going into forum governance, we have the GIP for the file data sources. I don't know why this doesn't have any GIP number, but it doesn't. There's a small comment regarding whether it would be possible for IPNS to also be supported. Of course, IPNS could change pointers at any point in time, so there's like potential difficulties there in allowing deterministic indexing of those contents. So yeah, it's just kind of like a small comment / question in the forum post. Then we have an update to the GIP 24 for query versioning. The main change is it basically creates the whole GIP and the draft for the GIP. And the main changes are to introduce a deprecation policy for all query versions and also to tighten restrictions around fixing determinism bugs. This is all coming from like discussions on the research and development retreat. Then we have an update to the GRP 0001 from Adam, which basically revolves around like some comparisons with older posts. I don't know if it was in forum governance or research, but regarding the potential to improve the, I guess, subgraph API to have some of the same things that are being discussed in the GRP 001. So he proposed to like follow those on their own separate places and maybe start discussing around things that are new in GRP 001, like the, I think, initialization handlers and how that could potentially work. Then we have a giant, and I mean giant, GIP for the Arbitrum DevNet. It's GIP 34. I think many of you probably saw this one. It is a giant post, so I would recommend everyone that is interested around the L2 scaling debate and how our approach is going to be to thoroughly read it, because there's a lot of interesting topics. It mainly revolves around how the initial DevNet for L2 will work and how the rewards mechanism will be adjusted to allow for L2 and L1 and L2 to coexist, and how it will be changing from time to time to adjust for like migrations to L2 and stuff. It is extremely detailed, particularly in how the drip functions will work, the formulas, the math formulas. So anyone that's interested in like thorough explanations, I think that's the main place to go right now. And there's also a notable mention to JP28, subsidized query settlement. There was a small comment from Jim trying to bump the discussion since it has been stale for like, I think, a month. And it's incredibly important to push this forward since it has like potential really nice impact in the network health. Mainly trying to gather more feedback from those that already participated and new participants in the discussion. To be able to move this forward to discussion in the council, if I recall correctly. For forum research, contracts, and network subgraphs, there's no new updates since last IOH. And I pass it to you, Abel.
Amazing. Thank you so much. So that is Protocol Watch and Repo Watch, our usual segments. And now we're going to move into an open discussion. And that open discussion is going to be on the announcements that were made during Graph Day and Graph Hack. So kind of a continuation on last week's conversation if you were all there. So what I've done is I've gone ahead and added a few topics from last week that we were unable to cover, and added an opportunity for everyone to vote. So if you haven't already, please do vote on those particular topics, and we can decide which ones we discuss first. But before we do that, I believe Chris would like to say a few words about a GIP, if I'm not mistaken. So Chris, take it away.
Thanks, Abel. Yeah, actually, I want to talk about GIP 24, which Juan mentioned. This GIP, I think it is, largely uncontroversial in that it's pretty clear that, at least to me, and I think many others, that the network needs this change. There are some consequences, obviously, for all participants, but naturally we're here in Indexer office hours, so we're going to focus on the indexer stuff. I'm sure many here have already read the GIP. I'm going to give a very, very fast whirlwind tour of it. And before we get into the open discussion, if anyone has any thoughts or perspectives to share on this GIP, that would be greatly appreciated. I know that there's an intent to move forward with this GIP quite quickly, so this is an opportunity to collect final feedback before we move through the governance process. In short, GIP 24 introduces query versioning, and this specifically versions the GraphQL API that Graph Node exposes for each subgraph. So I know, the Guild has been doing a lot of work on improving the GraphQL API that Graph Node exposes to consumers, things like, tightening the adherence to the GraphQL specification and implementing additional validations and so on. And so this has really raised the need for us to be able to version this API so that we can improve it without breaking compatibility with existing integrators. That's what the GIP is about. To kind of step through some of the changes or impacts that it covers. And I should say, Zach and the Guild have written this GIP, and as usual, it's very well argued and laid out. So if you're interested, please read the original. So any integrator, right, a client, a dApp, is written at some point in time. And when it's written, it is, being integrated against some live API. And so there's some expectation of the GraphQL interface available and the way in which it behaves. And if we, publish new versions of this API that improve its behavior and ultimately change its behavior, we obviously don't want existing integrations to break. And so with this proposal, clients would need to specify alongside, they obviously specify which subgraph they're looking to query, but they also specify a query version constraint, which explicitly defines, in terms of semantic versioning, the query behavior that the client is expecting. And I'm sure many of us are familiar with semantic versioning, but it essentially supports publishing new versions across patch, minor, and major number changes, and each one indicates a kind of different level of backwards compatibility of a given version versus prior versions. Semantic versioning critically also supports specifying version constraints. And that's important because we don't want integrators to specify a hard-coded query version. Like those APIs will improve, and they will improve in ways that are not breaking and that do maintain backwards compatibility. And so we obviously want integrators to seamlessly benefit from those updates. And so it's important that integrators supply constraints that might say something like, as long as I'm using a version, a query version for this subgraph that is of major version 1, I'm okay. And if the patch is 10 or 11 or 12, I don't care. So constraints are an important part of how this works. Now, other impacts, you would imagine that this also impacts query response attestations. And that's because the capabilities of the GraphQL API, right, the particular version of it, and therefore the shape of the query and the shape of the response, these are inputs to the determinism of the response from the indexer and therefore the attestation for that response. And so this proposal also essentially namespaces attestations by their query version. So every attestation is for a given query version, and there should be a single deterministic attestation for a given query with a given query version and for a given block hash. Hopefully all of that makes sense. Where this starts to impact indexers is that demand for outdated GraphQL query versions kind of becomes this additional dimension of demand. And to be super clear, I'm not talking about different subgraph deployments, but for a single subgraph deployment, and of course an entity schema that it defines, queries could be constructed for that very same subgraph that correspond with different query versions. One query version might allow pagination to happen in a slightly different way to another query version, but it's still the same subgraph and the same underlying data. But you can imagine that, there might be some application that continues to see, heavy usage that specifies a query version constraint that, starts to become old. And so there's this additional dimension in the market where, integrators will be requesting a given subgraph with a given query version API, and indexers, in order to support those queries, will need to, in turn, be running a version of GraphNode that can also support that query version. Practically speaking, I think GraphNode will support, essentially, most, if not all, of the query versions at the same time. Like I don't imagine a set of circumstances where indexers are needing to kind of juggle multiple versions of GraphNode in order to support multiple query versions. I hope and expect that will be fairly seamless, but it is this additional dimension of market demand that we should kind of recognize and understand. Okay, final thoughts here. So because query versions, which will now essentially become part of a query, when you make a query to the network, you'll specify the query version that you are expecting. Because these are now inputs to the determinism of query responses and attestations, this data input is important, right? Like it's an input to the cryptographic functions that uphold the data integrity of query responses. And because of this, this can't be just an arbitrary open input. There needs to be some trusted list of query versions that everybody agrees are valid. And for this, there will be a query version registry, which will be a contract deployed on chain. for those that have been in prior episodes, this will actually be a data edge contract. So we're seeing that pattern being used more and more in the protocol. And this registry will effectively just contain a list of the query versions that are valid and that have been developed by core developers and are subsequently supported in GraphNode. And of course, making a query attestation for a query version that is not registered or has been deprecated is a slashable offense. Okay, that's it for the whirlwind tour. I hope it made sense. Does anyone have any thoughts or any, I guess, criticisms of GIP 24? Anything that we should be thinking about before it moves ahead? Also, if there was any part of that tour that didn't make sense, I welcome questions, though I'm not the expert on this. I'll do my best to respond. Okay.
No questions? Sorry, one question. I also have it open. I just don't see where it might be touched on. For any existing implementations of queries that don't necessarily have a query version specified in their endpoints, are those just going to default to the latest version?
That's a great question. So my understanding is that there will be a version which will just be 0. So version 0 that will be grandfathered into the registry. So it will be a valid version, and I would expect that if a definitely don't take my word as gospel on this, but I would expect that the gateway would substitute, if no query version was explicitly defined, I would expect that it defaults to 0. I don't know, just because that seems like the backwards compatible thing to do. But I would also expect at some point that specifying a query version constraint when you're querying the gateways becomes a hard requirement. But what the path to getting there is, I don't exactly know.
So I actually had a question. From the perspective of the indexer who's not really privy to how the subgraphs that they're indexing are running, is there going to be any changes to how we do our job? Or is it going to be just like, we might see a larger database as we maintain multiple schemata?
So I can tell you what I expect. So that as far as I can tell, there won't be any impact to something like data size, because it is the same subgraph with the same schema and the same entities, and all of the underlying data is identical. The only difference is that for a given subgraph and entity schema, one version, one query version might expose a set of GraphQL query parameters that, say, allow you to paginate, with a skip and limit, parameters, and another version might, for example, switch to cursor-based pagination. But all of the underlying data is identical. It's just the query interface that is exposed on top of it. As I think, like, in the beginning, I think things will remain relatively straightforward, because I don't think there'll be this, fragmentation of actively used query version or client constraints that match different query versions. In the beginning, right, there's just not going to be much variance there, and I imagine things would largely continue as they do today. You could imagine a future where, you know, there is a strong amount of demand for a query version that is not the latest. In that instance, I still imagine that things for indexers don't massively change, because you would expect that GraphNode simultaneously supports all kind of commonly used query versions. Maybe there's some future where, you know, there's a massive amount of demand, or as an indexer looking to serve a very particular niche or application, you know, you run an older version of GraphNode that, you know, supports a query version that maybe a newer version doesn't support, but there's still some demand that you want to capture. Though it is worth saying that if a version is deprecated in the registry, it's effectively invalid. Like, as an indexer, you shouldn't serve or attest to responses for it. Did that answer the question, Kai?
That did. That's actually really helpful. So like today, if there's a change to a subgraph schema, it's going to result in a new deployment. And then if they wanted to introduce additional query functionality, that's what we're capturing in this versioning.
Not so if the GraphNode contributors, you know, the developers that work on GraphNode, which is ultimately the piece of software that exposes the query interface, if changes there were made, that would result in query version changes. The subgraph developer, you know, they don't have much control. Like, they have control over the schema, right? They can say, like, there are cats and dogs and mice, but they cannot, you know, really specify constraints or like configuration around how those entities are queryable, like how they can be paginated through or sorted, or, you know, things like that. So do you see that kind of separation where there's kind of the shape of the schema, which is defined, you know, in terms of the entities by the subgraph developer, and then there are, you know, the kind of the details of the interface that GraphNode actually exposes for that shape, and the filter and sort params and all that kind of stuff.
Got it. That makes sense.
Cool. Any more questions before we move on? Okay, if inspiration strikes later, please do drop a message on the forum in that GIP thread. I will drop a link to that in the stage chat. Yeah, onward and upward. Back to you, Abel.
Thank you very much. And thank you for the introduction to the GIP and that conversation there. So I can see that people have voted, and the number one topic that has come of this vote is Shellproofs. And luckily we have Jackson today, who I've invited to today's call to tell us a bit about Shellproofs. So Jackson, if you could give us a brief introduction into Shellproofs and speak about the announcement that was discussed on Graph Day, and then we can open up for some Q&A.
Yeah, sure thing. Can everybody hear me? I don't usually use
loud and clear, Jackson.
Okay, word. Yeah, good to be here. Shellproofs is a snark, which I think probably most people on this call have a rough understanding of what kind of primitive that is, but if you don't, you should ask. It's a new kind of snark that we synthesized with the snark force, and basically I can talk a little bit about the purpose for why we sought it out, but the properties of the snark that make it interesting and unique are that it belongs to this lineage of so-called transparent snarks, and transparent snarks don't require any sort of secrets or trapdoors, or I guess they don't require any sort of trust in a human committee in order to believe the validity of the proof system when it's invoked. They rely solely on mathematics. So that's what it means to be transparent. But the thing about transparent snarks is they struggle historically in other dimensions, especially in some performance dimensions. So usually transparent snarks, they might struggle with, prover time to produce one of these snark proofs. They may struggle with prover space. They also famously struggle with proof size. So usually transparent snarks have really, really large proofs. Like Starks is an example of that for just for the audience. And then also some of them also historically struggle with verifier time. So you get one of these proofs, how long does it take? How much compute does it take to validate one of these proofs? So those are the performance dimensions that struggle across basically all transparent snarks that we know of today. So yeah, Shellproofs is unique because it's a transparent snark. Its proof sizes are very, very tiny. It does not struggle in terms of prover time and prover space. And Shellproofs also has like a blazing fast verifier time. So it's kind of a best of all worlds snark, we think. And yeah, maybe I can stop there if there's any questions. If anyone's interested, I can talk about the purpose of how we want to use Shellproofs and what its motivation was. Anybody have any questions, or should I talk about the purpose and motivation, or should I pass it back to Abel or Chris?
I would say continue forward. If
Okay.
anyone has questions,
Please.
Okay. Yeah. So the motivation for Shellproofs was to more deeply secure the scalar payment channel or state channel infrastructure that we've been cooking up at Edge and Node and in the Graph community. The basic idea is that Zach and others they figured out pretty cleverly how to scale state channels to, I guess, involve a lot of parallel state channel games all at once. And the purpose for this was to basically not have this like serial dependency when you're using state channels between indexers and consumers, or I guess the gateway today, to not have this serial dependency. Instead, we wanted some of the guarantees that state channels can give us for off-chain security and micropayments for query service. We wanted to be able to do that at the same time as serving a lot of queries, high throughput queries that aren't blocked by this serial channel. So Zach figured out a way to basically instantiate 1 million state channel games all at the same time, and each one, you can think of each one of these games or one of these channels as kind of carrying one query for one micropayment. So this parallelization allows indexers to remain high throughput for the data they're serving. The only issue is that the way state channels, the way that they derive their security properties is there's a happy path where everything is basically super fine, and then there's a not so happy path where a consumer or a gateway could like grief an indexer or basically disagree with how much money the indexer wants to claim from the state channel. So all these accumulated micropayments, of course it's too expensive to ask the chain for each micropayments. You want to kind of close out an entire tab later in time after you've accumulated a lot of payments. So essentially on the happy path, you can go and do that. You can ask the chain for your payment. On the negative path, if a consumer, for example, disagrees, then the chain is stuck. The chain is the source of authority, but it doesn't know who's right and who's wrong. So the problem with having like 1 million parallel state channels is that accrues, like when you play these games and you accumulate funds into each one of these tabs, 1 million tabs, that racks up a ton of evidence that you would have to submit to the chain so that the chain could step in as kind of the court system, that they could step in as kind of the authority and pay you back the money that you're owed. So essentially that amount of evidence is somewhere, I forget the exact number, but it's hundreds of megabytes of evidence, if I'm not mistaken, I think up to 500 megabytes. And even just submitting the raw data, let alone checking that evidence, doing that in a smart contract is totally infeasible. It kind of explodes. And we did some basic math. I think it costs a few Lamborghinis literally in order to tell the chain to validate that evidence and give the indexer what they're owed. So one of the motivations for Shellproofs was we would like to prove with a snark that, like, we would like to give the indexer the ability to prove with Shellproofs that they actually saw this mountain of evidence, that they hold it themselves. And they can prove that, and that kind of rolls into this really succinct little proof that's only a few kilobytes instead of 500 megabytes. And they can submit that to the chain, and the chain can do, the chain, in under them the blocked gas limit, the chain can process that evidence, which is now just a tiny little proof that needs to be checked. And now the chain can know, okay, the indexer, the consumer was griefing the indexer, but the indexer was honest. And here's the indexer's payment that they have the right to have. So that was one of the early motivations to have a better snark in the graph network.
Cool. Any questions?
Yeah, so how would one of those proofs look on chain, and where would you store the rest of the data? Or do you even need to store it?
Yeah, great question. So the proof literally looks, so it's a few kilobytes. Let's say it's about 5 or so kilobytes for one of these proofs. And the proof data literally looks like random numbers. So it's indistinguishable from random junk. It might be a little hard to believe, but it is sort of, you can kind of think about it like the output of like an algebraic version of a hash function. And so, yeah, imagine kind of dumping 5 kilobytes of hash data into the chain, but somehow the chain, the smart contract has an algorithm that can process these random numbers and perform random tests on them to know that everything looks good. And then in terms of where the rest of the data goes, the rest of the data doesn't actually go on chain ever. This is something called witness data. And actually the data only stays with the indexer themselves, the single indexer that's going to argue their case. They use that data. In fact, they must use all of it. They use that data locally in order to produce a proof. But once they've produced a proof, the raw data itself, the witness data, is compressed away. It's just kind of gone. And this speaks a little bit to like the private nature of snarks. Like in this case, we take advantage of privacy not as a way to protect the indexer's secret business dealings. We take advantage of privacy in the sense that things just go away. They need not be included. And so for us, we look at that as a compression capability.
Can you speak about the I don't remember what it's called exactly, but basically prove that the query results are valid and representative. I believe that's something that will be handled with this with Shellproofs, right?
Yeah, I'm glad you brought that up. So we are currently in the lab. We are synthesizing some verifiable queries designs that call out to Shellproofs as a black box primitive. So yeah, because to handle scalar state channels effectively, we had to figure out what do scalar state channels do? What's the data involved and what's the computation involved? And luckily, the data and the computation is somewhat simple, but we had to model. We had to actually model what the scalar state channels do. We had to model that into these so-called arithmetic circuits. This is sort of the IR, the intermediate representation that snarks prefer to work with. So this is sometimes called the front end of a snark. And so for scalar, we had to essentially program the front end to tell our snark what it needs to do. The innovations of Shellproofs kind of come in at what's called the back end of snark systems, the actual snark protocols themselves. That's the back end. That's the magic or the engine behind these things. But we had to program the front end to to tell it to do what Scalar needs it to do. Similarly, for a query can also, actually any query can also be modeled as an arithmetic circuit. In fact, any NP, any computation in NP can be modeled as an arithmetic circuit. It doesn't mean you'll be able to model it with an efficient arithmetic circuit, but there are many programs of interest that can be modeled as an efficient arithmetic circuit that play nicely with the Snark backend and don't cause too much pain. So yeah, for verifiable queries, we're able to go off and try to use Shellproofs to see what it will give us. We're currently studying the properties and like the performance dimensions of in that context when we want to use Shellproofs. But the way that looks is like actually compiling GraphQL queries to a circuit description and then tossing that into Shellproofs, and it handles the rest. So the way that will look, it is a little different. I guess I'll say one more thing and then I can pause for more questions or comments, but it is different than Scalar, because for Scalar, we actually need a smart contract that understands how to verify a shellproof proof. But for verifiable queries, we likely don't need something like that. For verifiable queries, it's enough that a consumer in the browser, in other words, in WASM, using WASM, for example, if there's a WASM implementation of a Shellproofs verifier, which we're working on actively right now, if there's a WASM implementation, then it's enough that a Shellproof gets shot over to the consumer directly, and that proof validates a particular query against a particular subgraph that the consumer was interested in, and in 100 milliseconds or less, that little WASM code can verify the proof in the browser. And what's important to mention here is that even though the browser is sort of a resource-constrained environment, the chain itself, smart contracts are a far more resource-constrained environment. So we actually view verification in verifiable queries land to be, I guess, a lot simpler and easier than verification for Scalar, which has to happen on chain.
Nice. Thank you.
You're welcome.
Hey, Jackson. Thanks for joining and sharing. It's super interesting as always. The 10,000 times decrease in proof size is just like hard to comprehend. And we've kind of seen the enormous benefits of this. Forgive me if this is the wrong term, but this kind of computational compression that ZK proofs achieve, in so many different places. But one that comes to mind is rollups, and I guess I'd like to know whether you've thought about applications of Shellproofs more broadly across blockchain, and whether the thought of a Shellproof secured rollup has crossed your mind or something like that.
Yeah, great question. A lot of thoughts cross my mind every day. It's the nature of the work. I think I'll just say that the graph, like what the graph ecosystem and what Edge and Node and the core dev teams, what they need in the immediate future, they need something that secures Scalar. They need something. They need something for verifiable queries and verifiable indexing, which we're stepping up in the lab. And these things, I'll just say that these things are already hard enough, and that's definitely our immediate focus. In terms of so rollups are really interesting, and you brought up this compression aspect, and that's effectively what they do. I think a lot of people, they might underestimate what snarks really mean in terms of a new computational paradigm, because what they allow for is the compression of work and the compression of labor in a sense. And that's why they're a perfect fit for blockchains. So obviously rollups are super exciting. ZK enabled layer 2s are super exciting. And this is because, blockchains derive their ultimate legitimacy, and essentially their key killer apps they're all derived directly from this kind of redundant re-execution that happens at the consensus level. And so when you kind of start, when blockchains, they start from that. That's where like all the benefits accrue, and they come out of that source. And so when you start there and you realize everything has to be redundantly re-executed, you also realize you have a severely resource constrained environment, because you're asking basically 10,000, 20,000, 30,000 more nodes to just everybody repeat the same work. So yeah, layer 2s are super exciting. They allow for this different model, or sorry, ZK enabled layer 2s, they allow for this different model where if even a single person out there on the internet proves that something happened with integrity, and they prove that succinctly with a tiny little proof, then all of a sudden this massively expensive consensus machine need only pay the cost of verifying that proof is legitimate, as opposed to re-executing all the work from scratch. So it is, it's a dream primitive for blockchains. That's what snarks mean. Yeah, Shellproofs applied to that could be quite interesting, maybe. One thing I might note is that a lot of the big players that are out there doing ZK layer 2s and ZK EVM stuff and ZK rollups, I have to say, like, so much of it is marketing, and it's a little bit unfortunate. A lot of these systems that are deployed are not super secure. They're definitely not as secure as advertised. They have to make concessions and cut corners so that they can actually ship a snark people will be willing to use today. So they're kind of running and gunning for the first position in this big opportunity space. And for that, they're willing to make sacrifices. And somewhat shamefully, a lot of these teams are willing to make sacrifices that they don't make transparent to the public. And so one example is, Starks, for the same level of security that Shellproofs can provide, Starks are actually like many gigabytes in size, or many megabytes in size. But the stuff that Starkware is shipping comes in at like in the hundreds of kilobytes. And so like they're willing to kind of decrease security to make their proofs smaller, which we view as basically bullshit. So I think that there's room for a lot of epic innovations, not just Shellproofs, but other snarks. Like one thing we're happy about and we're proud of Shellproofs for is that it actually proves, it shows the world, like you can have a transparent snark that doesn't, that essentially doesn't have to fib to the public, that doesn't have to be artificially reduced in size to be able to be applied in the real world. So yeah, we'll see where that goes. And this is not going to be the last snark that we innovate. We'll make other new snarks too. And hopefully we can live in a world where there's, actually secure, transparent snarks that secure a lot of layer 2s. So I hope that answers the question.
Yeah, that's super interesting. Thanks for kind of venturing out into rollup land. We're got just a few minutes left, so just to shoot one more back at you, kind of going back into the graph. It's clear that substreams are likely the future of the way that many developers use the graph. And the kind of innovations around the runtime model and like the change in how that computation is actually executed are incredible. But it seems like if those computations were also amenable to proving, that would also be a complete game changer. How much have you thought about applying some of the zero knowledge work that the Snark Force is doing to substreams?
That's a great question. I'll just say up front that I'm not the most educated on substreams or the substream model, and maybe I should change that. I don't know if, some people are probably still on the call. They can maybe talk with me about that. So I guess in some sense, not a lot. I've not thought about it a lot. But in another sense, I want to correct maybe a misconception, because if part of what substreams are about is about mappings related to indexing, am I correct about that? That some stuff with the substreams model relates to mapping execution? Is that correct?
Yep.
Okay. So it's not, I wish that could be amenable to any snark that's out there. But unfortunately, like indexing an interesting subgraph that actually makes use of a lot of mappings and transformations, indexing one and then actually proving in the so-called forward direction using a snark, proving that you ran the mappings since Genesis until now, It's not going to be something that is available to basically any snark system probably for many years to come, maybe never actually. When you start working with snarks, you're in the region of like 1,000 times slower than native compute to 1 million times slower than native compute, if you're talking about proving you did computation correctly. So all the tricks, all the bells and whistles can push from like 1 million times slower into the 1,000, maybe 100 times slower region. So if it's already a pain in the ass to sync a subgraph from Genesis, that's an interesting and heavy enough subgraph, if it's already a pain in the ass, then it's going to be 100 or 1,000 or more times a pain in the ass to prove it from Genesis. But with that in mind, there's other techniques available for verifiable indexing where if you can prove that you did a single mapping that just took place between two blocks, then you can do some special magic involved with fraud proofs and some kind of hybrid between fraud and validity proofs. So we have a initial scheme for verifiable indexing that uses a design like that, but it's not something that requires, we don't believe it requires any real changes based on how substreams thinks of their own compute model. We don't suggest that they kind of change too many things in order to accommodate us. We think we have it covered already. So anyways, I hope that answers the question.
It does. Thank you very much.
You're welcome.
Over to Abel.
Amazing. Well, it looks like we're at the top of the hour, so we'll bring this conversation to a close. Just to flag something for you, Jackson, State Machine has posted a question in the chat, so if you want to go ahead and address that, feel free to. And amazing, wonderful. And there you have it. That is another episode of Indexer Office Hours. Thank you all for attending. As we always do, we do a POAP giveaway. But as we mentioned last week, we're still working through some POAP issues, just to give you some flavor as to what we're dealing with there. If you didn't already know, guys, every single POAP that you see, that you've claimed or see, is approved by a group of individuals, humans. And so there is this kind of approval process that we're currently going through. We're having some issues with our POAPs. So I'm kind of going back and forth with the team to get that ironed out. But nevertheless, we will reward you with a POAP. So again, like we did last week, if you could go ahead and put a +1 in the stage chat so that I can have a good indication of who is here, please do that. So then I will give you a retroactive airdrop for 63 and also 64, obviously if you attended 63 as well. So there you have it. That's it. Thank you all for attending, and we look forward to hosting another one of these next week and seeing you all there. Bye-bye.
Bye, everyone.
Bye, guys.
Bye, y'all.
Bye.